I'm going to talk tonight a little bit about Data for Good, which is a program we ran from the beginning of the COVID-19 pandemic. So as we're all aware, sitting at our houses right now instead of in an audience, the pandemic's really shifted the way we work and live. And Telus saw an opportunity here to try to help in the response to the global pandemic, but doing this in a way that was appropriate for us as a telecom company. So what we generated was this program we called Data for Good. And what we're doing is providing governments, health authorities, and academic researchers with access to our Telus Insights service free of charge. I'll get into a little bit more about what Telus Insights is in a few minutes, and then talk to a few really interesting use cases that this data was utilized for. And what we're doing is we're offering this in a supervised and guided way so that we can protect the privacy of the individuals whose data may be compiled into aggregate results, while still providing value to our government organizations and our academic partners in their research and in their understanding of what's happening with the pandemic. And what data we're using in this is telecom location data. So anytime a cell tower or a cell phone moves around a cellular network, it leaves residual events at the cell towers it connected to. Using these events, we can look at how many events happen per tower and how those events connect tower to tower. And we can do this without looking at individual IDs. And we're able to then pull trends of what's actually happening in terms of patterns of movement. And these can be incredibly helpful when solving different problems. And when I talk about privacy, this really is a critical piece of how we were able to do this and how we're able to do this successfully. When we're talking to government partnering organizations, the first question they're asking is, what are we doing to protect the privacy of the individuals within the data? It's also, from a company perspective, critically important. We really believe in the trust for our users, and we really believe in building trust with our users. So we're very transparent about what we do with this. It's on our website. We've got multiple pages discussing this. We've done bill messaging around it. And what we've also done is put out specific commitments about what Telus is going to do and not do. And there's 5 core commitments. These include, we won't use this data in any form for law enforcement. So we're not providing any information that could help law enforcement in pressing charges against people. It's not about enforcement. It's much more about prevention and understanding better what's happening. We're not providing any real-time data. So we're not going to give anything that's live. We don't want anything that can be tied back to an individual. And all the data is aggregated and de-identified. So this allows for us to show results in ways that are useful to customer or useful to our end users, but aren't infringing on our customers' rights. So what is Telus Insights? So Telus Insights takes this network mobility data, and then using various data science techniques, so different machine learning algorithms, different proprietary algorithms we've developed, we compile that data into actual analytics and results that are interesting and important. So these could be things like understanding the origin and destination of travel within an area. So I'm in Pickering right now. I commute to Toronto regularly when COVID's not happening. And what you could do with this is understand how many people have made that trip. So is it 500? Is it 1,000? Is it 2,000? This could be used by a service like Metrolinx to better understand what train scheduling they need to run on the train lines in this area. We also have algorithms that understand the speed devices are traveling at. This can be used to understand things like congestion on highways, effects of road closures, various other pieces of information that could be highly useful. The data is also commonly used in tourism to better understand what markets are being attracted, especially for Canadian internal tourism versus external global tourism, where there's much more data available from things like border crossings and airports. There's a lot less information available on who's traveled within the country. And so being able to provide information on which provinces are connected to each other can be very important, especially during a pandemic. We also have historic data on this going back to January 2019. So this allowed for a lot of year-over-year analysis and a lot of ability to put this in context. And as of September, we've launched an API that allows customers to pull this data directly through an API interface, getting those end results, so understanding the total numbers of people very quickly and efficiently. So I keep mentioning privacy, but I'm going to actually spend a bit of time on a slide specifically devoted to privacy. I spent the first 2 years I was on this team entirely dedicated to privacy. So we weren't doing anything actively in market other than building up our privacy stance and ensuring we were doing things in the correct way. So we worked with multiple different consulting agencies. We were the first Canadian company to get Privacy by Design certification, which was sponsored by Anne Kavukian, who's the former Privacy Commissioner of Ontario. She's behind the PHIPA initiatives around health. So when she was Privacy Commissioner, she launched that. And a lot of her language is what influenced the GDPR. So she's a very well sought after and a very well respected person within this industry. We also realized, though, that Anne's opinions on these things tend to slant towards policy, and policy is a very important part of privacy, but there's also the practical side where it's actually the algorithms being implemented to ensure that things like de-identification is correct, to ensure that aggregations and extrapolations are blocking and aren't reversible, so those are one-way functions. And so we ended up contacting Yves Alexandre de Montjoy, who's a researcher who was out of MIT labs at the time. He's since moved on to Imperial College London, but he worked with us on kind of building out those more mathematical approaches, and a lot of what's now called differential privacy. So it's adding in noise in the correct ways that we're not introducing anything that can be re-identified to any individuals when we provide things. On top of doing all of this, we also built things like an opt-out process that allows users to say, I'm not interested in my data being used in this. We don't ask any questions. We just remove their data immediately upon receiving those requests. Beyond this, we also audit every engagement with an independent party within the company. So with our data and trust office, they'll go in and audit every engagement we have to validate that the use case is not going to infringe on anything, that all privacy measures are in place, and that everything is checked and balanced correctly. And I already mentioned we got certified Privacy by Design on these products, that we were the first Canadians to do that. Finally, in 2020, for this initiative that I'm speaking about now, our Data for Good initiative, we actually won the HPE IAPP Privacy Innovation Awards. This is considered one of the highest awards you can receive in privacy in the international community. So we were very excited to win that in January for this program and what we've done for Canada. So moving on to what the actual use cases are. The first one's around understanding communities. So what we're doing is providing dashboards that look something like this to various different communities. So I've pulled up the Toronto one here for the week of March 6th that gives you an idea of how the area is trending in terms of mobility. So it shows things like the number of devices that we're seeing in the area, the year-over-year deviation. So how much is this different from the last week of February, first week of March in 2019? So we're showing a 38% reduction in mobility within Toronto during that time period. We're also showing things like the average number of devices for the week. So how many devices were there on average? How many of them came from outside of the CSD? So that's the census subdivision. So that's the city boundaries. And how many of them came from out of province, and how many of them were residents of the area. And so this gives you an idea of that breakdown and how that shifts. We also show some statistics that are ones that were commonly asked for. So we pull those out and put them front and center for our customers to see. And then we provide trend lines that show kind of the number of devices as well as the year-over-year deviation. So the number of devices is a whole number showing that volume. And then the year over year is showing that relative to a zero. So the zero being the average day. You'll notice there's a general sinusoidal trend to this based on where weekends are. So weekends, you tend to see reduced visit, and then you see it pick up again in the week and then drop in the weekend. What's interesting is that trend has continued during the pandemic, just at a much lower scale. So we're at almost half the number of people during the peak of the first lockdown. We got back up to nearly our normal, and then we dropped again during our second lockdowns that happened in December through January. We start seeing a real reduction in the amount of movement in Toronto. This is another view of this. This is showing which communities are getting travel from Toronto. So this is showing the amount of people who have left Toronto and gone to these communities, and which communities are seeing increase as a relative percentage to what they saw in 2019. And we're looking specifically over the Christmas holidays, as there was a lot of discussion on how many people were actually moving, especially post the lockdown on December 27th. And you'll see as this is flipping around, there was a significant amount of movement leading right up to New Year's. And then on New Year's, there was a sudden reduction in that movement, and then movements kind of dissipated back down to normal. And this is interesting for epidemiologists to see, to really understand which communities are interconnected and can really inform where policies are working or not working. So this is the next use case, which is on determining the origin of travel. So this is a case from the summer where we were looking at the number of people who went to Wasaga Beach during the May 24th long weekend and seeing a massive increase with 90% more people on the Saturday of the long weekend on May 23rd entering Wasaga Beach. So this is a significant increase, especially during the prime of the first wave of the pandemic. It got to the point where the mayor actually shut down the beach and put this in place to try to stop this and curb the amount of people coming up. And we're seeing this in the data very strongly that a lot of people were doing this. And it puts risks and strains on the health systems in these smaller communities. We can also see this here with kind of a pre-pandemic versus post-pandemic look. So looking at that breakdown and seeing where those visitors come from. The one interesting piece is it's a 10% increase in visitors from Toronto specifically, and that's a very growing concern. We also showed Barrie, which is a nearby city, to show a comparison of how that shifted. And Barrie saw a much more typical volume, whereas Toronto saw a significant increase in the volume of travelers coming to Wasaga. And the final use case I'm going to talk about is measuring connectedness. And what this is doing is actually building maps of how communities are interconnected with each other. So this is looking at a map of where people from Vancouver travel to on a two-step basis. So it's saying if someone leaves Vancouver and goes to Victoria, for example, then they may also go to one other community from there, and it's showing where those connections happen. This can be really important for health organizations when they're trying to understand where disease outbreaks might happen next before numbers come out. With the lag time on and lead times on case detection, it's really concerning because as an outbreak happens, there's probably another outbreak happening one community away. And if you can't get ahead of that, this will just continue to spread. So things like this allow for public health to make decisions about which communities they should be putting effective messaging in, and better promote messaging that will work in those specific communities. So this could include using non-standard messaging, so not just coming out on TV or radio or through internet ads, but looking at community leaders to come out and speak, or looking at different ways of reaching the communities. And this is showing a real strong effect at deterring spread as you look at the specific messaging you need to provide to each community. So that's our Data for Good program.
Curious to know, I mean, I think it's really interesting to see this data, really insightful. I think when we kind of, specifically relating to this, when we kind of see the data, it's a little bit kind of a late, I suppose. It's like, oh, look how far it's spread. What do you think, or how do you think the specifically Telus Insights could maybe potentially preempt some of this movement? Is there a way to study and kind of make predictions as to where we think people are going to go and then somehow restrict the movements? What are your thoughts there?
So yeah, this has been an interesting debate about how you can use this data to really help. And one of the ways, it's not even so much about predicting what that movement's going to be, but it's monitoring that movement and then predicting what will curb that movement. So looking at how different policies and different messaging works. So you can look at it as almost A/B testing of messaging. So public health agency says, hey, please stay at home. We really appreciate it if you stay at home. And they use very soft, polite language. Well, if we see then an uptick in travel immediately following that, that messaging is not going to work. And so you look at how you adjust that and how you do things. So you see this in Ontario. So we've been working with the Vector Institute. There's a press release coming out next week on this. And they've been looking at how this data can predict where outbreaks are going to happen based on the volumes of people you're seeing that are not from that area. And they're also looking at how you then message areas where you're starting to see those upticks in volume ahead of time, so that you can get effective messaging. And we see Ontario shifting their messaging strategy from those very polite, cartoony messages to their current messaging showing people on ventilators and saying a simple coffee is not just a simple coffee and things like that. And they're seeing the effects of those different messaging and adjusting according to how people are actually reacting to it. And I think that's what this data is really good for. It's a tool within the total toolkit for public health.
I think that's a really interesting poison, isn't it? It's like, stay at home, please. You will die if you go to the beach. Very different messages, but what's going to work? I think that's what we kind of need to understand, is what is getting through to people. So yeah, really, really good insight there. Can you repeat what is the raw data you're using to produce these results? Did I correctly here, it's aggregated flow data at the base of cell towers?
Yeah, so this data is what's called network ping data. So it's when network towers communicate with your phone. So if you send a text message, a phone call, if you get data coming to or from your phone, it's communicating with a cell tower. But what people don't realize is also when you move, your phone communicates with the cell tower to say, hey, I'm still here or I'm now here, so that the network can then send you those things. And so we're picking up those breadcrumbs as the phones move, and we're able to pick those up at a base station level and then understand how that movement works throughout the country.
On the kind of the law enforcement side of things, because I mean, people go missing all the time, and I mean, we have these Amber Alerts and stuff like that. How or is Telus working in any way with law enforcement to track? Say we've got an Amber Alert for a missing persons. You know, can the police access this data in real time to see, hey, where is this? Oh, well, they're heading up the 401. Let's send a couple of cars there.
So this data is not at an individual level. So there's no identifiers to tie this back to an individual. And that's a really critical piece of the privacy stance. So it's not intended for law enforcement. We also don't allow for law enforcement to use that data. They're on kind of our red list of organizations we don't work with specifically. We do have, as a company, a court order liaison team that works with court orders. So the courts can mandate that we provide detailed information to law enforcement when they have a warrant and they've gone through that process to get that. But we require a warrant, and Telus has actually taken a stance against large, what are called tower dump warrants, where police asked to just see every phone that was on a specific cell tower at a time. And that went all the way up to the Supreme Court of Canada, who ruled in favor of us not releasing that type of information. So they need to have a named suspect they're looking for. Again, we take very strong stances on our users' privacy, and this program emulates that, as does the rest of our business. It's a very critical stance for us.